Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on probability, lecture number 12, in which I will solve some problems on conditional probability. Now we solve a problem. Problem is 10 cards numbered 1 to 10 are placed in a box, mixed up thoroughly, and then one card is drawn randomly. If it is known that the number on the card is more than 3, what is the probability that it is an even number? Since the cards are numbered by the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 number of cards. So, sample space will be a set containing number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, what is the probability that it is an even number? Let A be an event that denotes that number drawn on the card is even number. Among these, we have even number 2, 4, 6, 8, 10. Now here it is known that the number on the drawn card is more than 3. Let B be an event such that the number on the drawn card is greater than 3. Therefore, it will contain number 4, 5, 6, 7, 8, 9, 10. Now, B is given, B is known. Firstly, we find the probability of A, probability of B, and probability of A intersect B. PA, probability of event A. In A, number of elements 1, 2, 3, 4, 5, and number of elements in sample space is 10. This is 1 by 2. PB, probability of event B. Here in event B, number of elements 1, 2, 3, 4, 5, 6, 7. 7. Number of elements in sample space is 10. A intersect B. A intersect B gives number 4, 6, 4, 6, 8, 10. Now, P A intersect B. Here number of elements in P A intersect B is 4 and total number of elements in sample space is 10. That means 2 by 5. We have to find the probability of the event A if the event B is known. That means we have to find the conditional probability of A if the event B is known. That means probability of A slash B, and this means PA intersect B by PB. PA intersect B is 2 by 5 and PB is 7 by 10, and this is equal to 2 by 5 multiplied 10 by 7. That means 5 2s are 10, means 4 by 7. Now we solve the next problem, problem number 2. In a school, there are 1,000 students, out of which 430 are girls. It is known that out of 430, 10% of the girls study in class 12. What is the probability that a student chosen randomly studies in class 12 given that the chosen student is a girl? Here, number of students in the school be 1,000. Let collection of all students be denoted by S, sample space, which contains number of students 1,000, that is number of elements 1,000. Number of girl student, this part is number of girl student, this part. Here set of girl student is denoted by G and number of girl student be 430, this side. And this set is students of class 12. Here given that it is known that out of 430, 10% of the girls study in class 12. Means 10% of girls, means 10 by 100 multiply 430 equal to 43 girls students study in class 12. Now we have to find the probability of a student chosen randomly studies in class 12 given that chosen student is a girl. So we have to find the probability of student class 12 given that chosen student is a girl. And this means P students of class 12 intersect girl student by probability of girl students. The circle denotes the students of class 12 and dotted portion is the number of girls students of class 12 and this number is 43 and 43 this number and the set G has common place this dotted portion, that is number of these students will be 43 by total students 1,000. Here PG probability of girls student, total girls student 430 by total students 1,000 and this will be equal to 43 by 1,000 multiply 1,000 by 430. This is 1 by 10 means 0.1. Now we solve the next problem. Next problem is a die is thrown 3 times. Events A and B are defined as below. Event A, 4 on third throw. Event B is 6 on the first and 5 on the second throw. Find the probability of A given that B has already occurred. we have to throw a die 3 times. So each element of the sample space will be of order triplet. Here A be an event such that 4 on the third throw. Therefore A will be a set containing all those order triplet such that this 4 will be as a third component of this order triplet, third position. And in the first and second position, be A and B. A and B may be 1, 2, 3, 4, 5, 6. The first place may be filled in 6 ways by numbers 1, 2, 3, 4, 5, 6. Simultaneously, the second place may be filled by number 1 or 2 or 3 or 4 or 5 or 6. 2 works are done simultaneously. So, number of elements in A will be 6 multiply 6 means 36. Here 4 be fixed. So, NA equal to 36. Here B, 6 on the first and 5 on the second throw. In third throw, it may be any number from 1, 2, 3, 4, 5, 6. So C may take 1, 2, 3, 4, 5, 6, any one of these. So number of elements in B will be 6. Since 2 places are fixed and we have to fill the third place by 1 or 2 or 3 or 4 or 5 or 6. Now A intersect B. Here in A third place is 4. So here we have to get 4. If we give here 4, then number will be 6, 5, 4. Means A intersect B will be single element 6, 5, 4 order triplet. So N A intersect B equal to 1. Since for a single die, for single throw, the number of elements in sample space be 6. So for throwing a die 3 times, the number of elements in sample space will be NS equal to 6 multiplied by 6 multiplied by 6, 6 cube. Here we have to find the probability of A given that B has already occurred. Means we have to find the conditional probability of A. B has already occurred. B has already given. And this is equal to P A intersect B by PB. And this is equal to N A intersect B by NS by NB by NS. NA intersect B is 1, NS is 6 cube, NB is 6 by 6 cube, and this is equal to 1 by 6. Now we solve the next problem. Problem is, consider the experiment of tossing a coin. If the coin shows head, toss it again. But if it shows tail, then throw a die. Find the conditional probability of the event that the die shows number greater than 4, given that there is at least one tail. Now we solve this. So firstly we throw the coin and we may get head or tail. It is given that if the coin shows head, toss it again. Toss it again means again we may get head or tail. That means firstly we have already got head, now head or tail means here we get outcomes HH, HT. Two outcomes. Here if the coin shows tail, then throw a die. Die contains number 1, 2, 3, 4, 5, 6. So if it was tail, then by throwing die we may get 1, 2, 3, 4, 5 or 6. That means T1, T2, T3, T4, T5, T6. So outcomes are HH, HT, T1, T2, T3, T4, T5, T6, and we collect this and make a sample space. Here we get 1, 2, 3, 4, 5, 6, 7, 8 numbers of outcomes. But all outcomes are not equally likely. Because here if a coin is tossed, then probability of head will be half and probability of tail will be half. And here we have half probability, then again we toss the coin, we may get head or tail, that means HH or HT. That means here we have probability half, then half multiply half, 1 by 4, and half multiply half, 1 by 4. Probability of HH be 1 by 4, probability of HT be 1 by 4. Here probability of tail is half, and here we have T1, T2, T3, T4, T5, T6 means 6. So here we have probability 1 by 2 multiply 1 by 6 means 1 by 12. Probability of outcome T1 be 1 by 12. Probability of outcome T2 be 1 by 12. And in this way probability of outcome T6 is 1 by 12. So here probability of HH is 1 by 4, probability of HT is 1 by 4, probability of T1 is 1 by 12, probability of T2 is 1 by 12. In this way probability of T6 is 1 by 12. So all outcomes are not equally likely. Now our event is the die shows the number greater than 4. E be the event, let, and greater than 4 is here 5, 6. So here we have two elements T5 and T6. And if be an event, there is at least one tail. Here tail, here we see tail, here tail, here tail, here tail, here tail, here tail. So F will be an event containing HT, T1, T2, T3, T4, T5, T6. Now probability of event F be the sum of probabilities of all its outcomes. Probability of HT be 1 by 4. Probability of T1 is 1 by 12. Probability of T2 is 1 by 12, and in this way probability of T6 is 1 by 12. Therefore probability of all outcomes of event F will be sum of these probabilities. This is equal to 3 by 4. Now, E intersect F contains two elements T5 and T6. Probability of outcomes T5 be 1 by 12 and probability of outcome T6 is 1 by 12. So, probability of E intersect F is 1 by 12 plus 1 by 12, that is 2 by 12 equal to 1 by 6. Now, we have to find the conditional probability of the event E. The event F is already known. That means probability of E slash F. That means equal to probability of E intersect F by PF. PE intersect F is 1 by 6 by PF is 3 by 4. This is equal to 1 by 6 multiply 4 by 3 equal to 2 by 9. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.